Folks, let me walk you through how I would approach finding the area of the complete polygon that you've drawn with the interior triangles. So previously on the other video, I showed you how to use the online ruler and protractor to get lengths and to get angle measurements, which I did. And I labeled my polygon accordingly. This time I'm going to come on in and actually segment out the triangles. So here's one that I see is this triangle, this other one, and then this. So you're going to see that there's 4 different triangles. One of the things you have to do is you have to find all the side lengths that we drew on the inside, those 3 red lines. I have to use math to find those. In addition, I have to remember all the angles that got created. So there's 10 other kind of those smaller angles. So if you take a look at it, right, we're talking about all these right there. I mean, there's 4 angles. Here's other 2 more angles. Here's 2 more angles. And then these 2 angles. So we're going to have to use our trigonometry to find those orange angle measurements for all of those spaces. And you can do it one triangle at a time. You can do the entire shape, however you'd like to approach it. I'm actually going to do this one triangle at a time, and I'm going to call this guy here triangle A. So for triangle A, I'm going to go ahead and maybe I'll find all the missing, the side lengths and angles first. This first side length right here, I'm just going to call side length X, and that's just this guy. So I can easily look at that and come on in and just do Pythagorean's theorem. So for that, why don't I just show the work? I'm going to do x squared equals 4 squared plus 6 squared. I'm going to come in and take the square root, and I get approximately 7.2. So I'm going to come in here and actually change this now to 7.2. Maybe keep x equals there. So I have it in my picture, and I can support the math that goes with it. How about some of the missing angles? Well, I have this angle here and this one. Well, if I find one of the angles using maybe SOHCAHTOA, because it's a right triangle, I could find the other one using 180 degrees for a triangle. I'm going to call this angle A. And to solve that one, I'm going to come on in and say the tan. So I'm going to do the tan of A equals 4 over 6. Well, to find the measure of angle A, I'm going to do the inverse tan. So tan -1 of 4 over 6. And when you simplify that, what you get is actually 33.7. So I'm going to jot that down here, that this is 33.7 degrees. Well, can I find this third angle here? Sure, that's easy. I'm going to call this angle B. And what I'll do here, I'm just going to say angle B is equal to 180 minus the 90 minus the 33.7. That's going to give me the 56.3 degrees, and I can fill that in here at 56.3 degrees. Now, the last thing I'm going to do with this triangle is why don't I go ahead and actually compute the area. So the area of this triangle, I'm actually fortunate it's a right angle, so I can just go ahead and do the area formula of 1/2 base times height. So let's go ahead and do that. I'm going to do 1/2. The base is 6. My height is 4. That gets me 12 squared centimeters is that area. So in terms of that first triangle, I have all the side lengths that I added and the missing angles, and I have the area. So triangle 1 is done. I'm going to go on to triangle 2 now, or I should say, I'll call it triangle B. So if I look at triangle B here, one of the things when I first noticed is it looks like this might be a right angle. I can't assume that because this one angle I measured was 135. I cannot just visually look at it and say it's 90 degrees. I have to mathematically find that angle, so be careful. And it looks like we're going to have 3 angles we do have to find, so quite a bit of work for this one. If I just highlight those angles, we have this one here, this guy, and this guy. Now, this one down here is going to be fairly easy to find. The whole angle I know is 90, so I can compute that very easily. I'm just going to go ahead and do that now. I'm going to call this angle A. So angle A, maybe I'll just type it up here. So A is just going to be 90 degrees minus my 33.7. That is going to get me the 56.3. So I can actually fill that in at 56.3 degrees. The other one I should find. Now, do I want to go ahead and try to find this angle. Well, I know this whole thing is 135, but I only know one. I can't do some nice math on that yet. This guy here, I don't know anything, so I can't do that. I'm going to have to do some type of algebra or trigonometry to get me there. And what I first see to do is I can't figure out how to get these missing angles. So what I'm going to do is try to get this side length. This missing side length I can actually get by doing law of cosines. So law of cosines, here's the side angle pair, and here's the other two sides. So if I write down law of cosines for this, I'm going to go on up here, and law of cosines is just going to be, that was side x, so I'm going to say x squared equals, well, let me actually put it up here so you can see it better. Actually, let me erase this. I'm going to say that x squared equals the two sides squared, so 4 squared plus 7.2 squared minus 2 times the 4 times the 7.2 times the cosine of 56.3 degrees. Now to solve for x, I just need to take the square root. And when I do that, I can actually find that the side length of x here ends up becoming, it's approximately the number 6 when I round. So I'm going to label that as 6. Now, I do have enough information to find one of the other yellow missing angles. So what I could do is find this one. I could do a nice law of sines pair. So this angle partners up with that. This angle partners up with this side. So why don't I go ahead and do law of sines? What I can do here is maybe I'll call this angle C. So I'm going to say the sine of angle C over 7.2 equals the sine of the 56.3 over side length x. To solve for C, I'm going to do the measure of angle C is approximately the inverse sine of the 7.2 times the sine of 56.3 all over 6. When I do that, what angle C ends up equaling out to be is about 86.7 degrees, it looks like. So I'm going to do, it's approximately 86.7 degrees. And I can label that at 86.7 degrees. Now, it's not 90 degrees because we did rounding, so that makes sense. Because this value, whoops, sorry about that, because this value here, 7.2, is rounded, that's why you're not seeing this come out to be exactly 90, even though it probably in like a real life scenario is. That's okay. I want to see the 86.7. That makes more sense to me than it being 90. 90 really isn't valid for this case because of the rounding issue. Now, to find this third angle, what you could do is just do the triangles 180 and subtract this one and this guy here. So why don't I go and do that? I'm going to erase my work up here just because I'm running out of room on my demonstration here. And I'm going to call this angle D. So I'm going to say the measurement of angle D is just going to be 180 degrees minus the 2 that I just found here. And what that is going to do is give me the answer that this angle comes out to be approximately 37 degrees. Okay, I have all the information for this triangle, so now I can compute the area for this triangle. All I need to do for that is go ahead and I'm going to use, again, let me erase this previous work. This is triangle B, so for that, I'm going to do the area of B is going to be 1/2. It's A and B. So I'm going to actually use the 4 and the 7.2. Because I'm choosing 4 here and I'm using 7.2, I have to use this angle for law of how law of sines works for the triangle area formula. I'm going to do the sine of 56.3 degrees. When you do that, this actually ends up rounding out to be about the number 12, which logically makes sense because this triangle here and this triangle here really are the same two triangles. It's just a rounding issue that we saw with some of these other elements here. Now, as we continue to look at the next two triangles, I have triangles C and D. I'm just going to highlight triangle D for you here. In terms of the area formula, triangle D is ready to go. It's already set up for 1/2 AB sine of C because I have the two side lengths and their corresponding angles. So I could easily compute that. And I'm not going to write that down because you can just see how the formula would work. What you would have to do for triangle D, though, is find this little missing angle, this one, and this little, and the side length. For triangle C, we have to find this missing angle, which we can easily do. You're going to have to do some more work to find this little guy. So I'm not going to address any more on these two triangles, C and D. I think walking through triangle A and B and showing you how to do that should give you some insight. So just think about how could you complete triangle C. Again, we can easily find this angle, and we know this side length here. Some of the things you're probably going to have to notice is we have this side length, we have this side length, and we can find this angle. So if you have these two side lengths and this angle, what can you go ahead and do? Well, you can easily go and find this corresponding side over here using law of cosines. So you can use law of cosines and find that missing side length. Getting the area for this triangle is not difficult. The information is there. We're probably then going to have to use some law of sines to come on in and find some of these missing angles here and properties of triangles. Hopefully, walking through this is giving you some idea of how you can go about just kind of going step by step. I encourage you not to get overwhelmed by this project, but then again, just go step by step. Once I broke it into the 4 triangles, maybe start with one of the triangles that seems the easiest for you. Find that area. I chose this guy down here, which was my triangle A, and then just started building and filling in the pieces as you go. Take it piece by piece, and email me with any questions that you have. I hope this kind of walkthrough help you kind of gain an understanding of how you can approach completing this assessment for yourself. Good luck.